Hello, fellow. My name is James Owusu-Appiah, and I believe in innovation and doing things differently. This video has been prepared for you to guide you through some well-known concepts that will aid your studies and preparations towards exam. Due to COVID, we cannot meet in person to discuss, so I hope this video finds you well and helps you achieve excellence. Thank you.
So I just want to also look at this and then see that how these things are coming about. So let's try and write our syntax first, and then let's see. Let me just focus on the syntax. So yeah. So let's see the syntax. Ours is going to be what? So we are going to use the first 8. I just try copying and then bringing it here so that it can be. So we're going to focus on it here, right? So this is our jump. Yeah, so this is our jump, and then we are going to so the purpose is what it does is we're going to jump to an address within what our program or the instruction memory. We're going to jump to an arbitrary location or address within the program memory. So that is it, and then this is how it's going to be. So the syntax is of this form, right? So the jump, the location, that is the instruction, and then the location, and then the operand is the location I want to jump to. And then this operand, the location is any value between 0 and from 0 up to what 2 raised to the power 8 minus. In this location to rather LL so that it become kind of easier. Later you'll see why. So location L, I don't know, just something to make a little bit space, right? So let's see. Maybe I'll have to maintain it that way, but let's just see something else. Okay, let me just make it L, the location, right? Jump location. Now let's write the operation code. You see, all our instructions as a whole, we want to identify every instruction with a number or something, like a code to kind of identify every instruction. So we will let's see the operation code for jump. So the operation code. So what this instruction will be that. So we will do adjustments, right? So let me still maintain location. This to location, and then yeah, let me still keep it to location. So let's just use location, and then location, right? Now let's see the opcode for this instruction, right? So we'll use a 16-bit opcode, actually 16-bit opcode or something for the instruction. So the 16-bit will be divided such that you see it will be divided such that the first 8-bit will be the instruction. So the first 8-bit, so the first 8-bit will be the instruction bit, and then the next 8-bit will be what the operand or the location in this case. So it's going to be like this. So first of all, let's give an opcode or like an opcode to jump to be able to identify the jump instruction. Since our first instruction, we'll just give it the code like 1. So and then 1 in binary, or using our 8-bit 1 in binary, that doesn't be 000 up to 1. So let me just write that 1 2 3 4 5 6 7 8. So 0001, that will be the operation code or the opcode for the first 8-bit, which will be the jump, and then the next 8-bit 1 2 3 4 5 6 7 8 will be the location. So let me just do that. So this is jump, okay, then jump, okay, and then this is a location. So this is how our opcode is like. Sorry that for that delay and stuff. So this is how this is how we would this. So this is the description of our instruction. So with all these, we can now be able to implement this instruction because we have everything that we need to know. We have all that we need to know about the instruction, so we can be able to implement it. So let me just try and go over these things so that it doesn't look confusing. So yeah. And the reason why I tried to show you the AVL how is I just want for you to have an idea of how these things, real, our true system implement these things. So this is how we're using the jump instruction, and we say that the purpose of this jump is what to kind of jump to an arbitrary location, as you can see here in our instruction memory. And then this is a syntax that we are going to, this is how it's going to be like in memory. So we'll use 16 bits for the entire stuff, including the instruction and then the operand. So here this is the operand where we want to jump to location. So in that case, we have the instruction jumped, and then we say that because you see we'll have series of instructions, so it just makes sense that we should be able to assign a specific number to every instruction that we work with. And then the jump is our first instruction, so we just decided to give it number 1, and this 000 this is in binary, so these are binary numbers. So this is 8 bits, so the first 8 bits is for the jump, and then the next 8 bit is the location that we want to jump to. So this is the opcode, so this is the 16-bit opcode, and this is the same format or the rest of our instructions will follow. So 1 2 3 4 5 6 7 8 bits. And then so we'll see the syntax, and I hope you understand how this syntax is like. And this is the infer that the jump has. So after executing the jump, this is the infer. It has an infer on a program counter. So what it means is that the location will be loaded into the program counter, as you can see here. So that's all for the jump instruction, right? So yeah, this is one of our instructions that we will have. So next, let me also look for other instructions that we need, right? I will not take the AVL instructions. There are a lot of them, and then they are a little bit complicated and stuff. So this is fine. I have an idea of how the actual thing works. So let's be what was here to here, right? So the load, right? So this is a description. What it will do, it will load a value into the accumulator from the instruction memory. So that will be the function of what? The LoadAI. So this instruction, you can give it a name or something. So you yourself can do anyhow you want to name it. So we have the LoadAI here, right? And as our instruction. So with this instruction, if we implement this instruction, what it means is that we will be able to move a value from memory into this register, the accumulator. And I said the accumulator was a special register. That's how we're addressing it. We're making this a specific instruction to kind of work with it direct. So it kind of faster to work with the accumulator compared to the other registers. So you will see later on how that's coming to play. So now we have an instruction to be able to move a value from memory to the accumulator. So let's see. So let's continue with that and see. So this is the syntax of it. So the LoadAI, it will take one operand, and that will be the value that we want to load, or the value that we want to send from memory to the accumulator. And then you can see this value, of course, is going to be an 8-bit value. It's an 8-bit machine, so it'll be an 8-bit value. And then at the end of the day, this is the infer that we'll have. The program counter, accumulator. Sorry, let me change that. That's one thing about copying and pasting. So accumulator, so this is the infer that we have on our accumulator. So this value will be what loaded into our accumulator, and that's after executing this instruction. And we can also give it a form. It's still going to be, then let's give it an opcode, right? Let's give it an operation code for the LoadAI. So since it's our next instruction, we'll just give it an operation code of what 10. This is binary, so from 1 will go to 2. So this will be the operation code for this instruction, and then that will be the operation code, and then we will have let's see. Okay, so let me just copy and paste for this here. That way it make my life easier. All right, so let me try and kind of give it this. So it's going to be a 16-bit. I don't and it's that's, let me back put a LoadAI, and then this is going to be value. So this becomes a value they want to load. So our value, and then the operation code is going to be 10. So just take note of this and then try to follow like what I'm doing here. It's not nothing specific, but it just it's good to always write your instruction this way, then you know exactly what they are to do, so that if you program your control unit and then it's not working the way you expect, then you can come back and use this as a reference to your system. So load a value into the accumulator from the instruction memory. Then we'll have a load okay, this is the instruction, and then this is it's also going to be a 16-bit opcode, right? So the first 8 bits will be the instruction, and then the next 8 bits is going to be the value that we want to load. Now the XX, now we don't know the value. It could be any value, but it should just be within what, in this range. That's just what we are saying, and this is the input of the instruction. So in the same way too, we'll have other instructions like so let's see another instruction that we'll have, right? That'll be, so now the load AI, we can now move a value from the instruction memory to the accumulator. We also like to be able to move a value from the data memory into the accumulator. So let's have another instruction call. I will just call it there is a load so from load into the accumulator from the data memory. So I say load AD or something like load AD. So that we are loading into where the accumulator, and then where are we getting that value from the data memory. So let me show you that here. So the data memory, so we would like to be able to move a value from the data memory into the accumulator. So the load AD will take care of that. And let me also write another instruction that we'll need, then later I'll add a description. So another instruction that we will need also will be, we also like to be able to move something that is in the accumulator into memory. That is it. Yeah, we would like to know the accumulator store things temporarily, so we would like to be able to store something that is in the accumulator. We would like to be able to move it into the data memory. So as a result, we'll have another instruction. You can call it store, right, into the accumulator from the data memory. You see, so we have another instruction called store AD. So we are storing a value into the accumulator, and then where are we getting that value from the data memory. So as you can see, even just with these 4 instructions, right, just with these 4 instructions, we are able to move a value from the program counter here into this memory address register or something like that.